Okay, a couple of things we need to review before we do the first example here is how to solve a quadratic. If I have a quadratic of standard form, I can factor that, right? If a is 1, and they will be, how do I factor? Do you remember? I start with the c and I say, what do I multiply equals c, but add equals b? And most of them today will be factorable. If it's not factorable, then we have what we call the quadratic formula. Okay. So if you have a quadratic and you need to solve it, first step should be see if it's a factorable, because most of them are going to be. Your book is nice to you and gives you problems that are factorable. If not, then quadratic formula solves any quadratic. The other thing we need to go over is if I have a binomial squared, like x plus 3 squared, how do I square a binomial? What does x plus 3 squared mean?
Means 2x plus 3.
Okay. X plus 3 times x plus 3. A lot of students, when they see this, they want to say it's x squared plus 9. And that's not the case. You just can't square both of them because it means this, and this means a FOIL, first, outer, inner, last. So I do first, outer, inner, last, and I get this. Okay, but I wanted to show you a shortcut of this since we're going to be doing this a lot today and it takes time. When you are doing a binomial squared, there's a saying, kind of a rhyme that makes it go faster. And you do this. You square the first, take the first times the second times 2, square the last. That's the saying. You'll use this a lot in this section. A lot of times when you get into pre-calc and you do ellipses and circles, you have a lot of binomial squareds. So this is a saying that makes it go faster. I didn't make this up. This has been around for a long time. I remember using it back when I was younger.
Whoa, that was a lot.
Okay, but what does this mean? This means square the first term. Square the first means square the first term. So x squared. Take the first times the second times 2. So x times 3 times 2, 6x. Square the last, 9. See how you get the same thing? But it's going to, if you do this, right, and just if you say it a couple of times, it kind of flows so you can remember it easily. Square the first, take the first times, second times 2, square the last. And then it makes it go a lot faster than having to write it out in FOIL. The first example here, you're going to still follow the same steps that we did Wednesday. You're going to isolate the radical or rational exponent. Okay. I'm going to throw some terminology into that first statement, though. You're going to isolate the radical or rational exponent if possible. If you look at your examples, you'll notice that some of these have 2 radicals in them. And then, of course, your second step is you raise both powers to whatever the index is or the reciprocal of your rational exponent. Okay? So step 1 is done. All I have on the left side here is the square root. What am I going to raise both sides to? What power? You're going to square both sides. Right? Because a square root and a squared cancel out. So I get 3x plus 7. And this is where we're going to have to square a binomial. Because you just can't square the x, square the 1. You have to FOIL that. So let's use our shortcut. Square the first. Take the first times second times 2. Square the last. And hopefully you remember that a negative squared is always positive. So you'll always get a positive number there. Okay. Now this is quadratic. To solve a quadratic, if you remember from a couple of chapters ago, we needed to set equal to 0. So we have to subtract the 3x over, subtract the 7 over, And then once it's set equal to 0, then I can try to factor it. What do I multiply equals negative 6, but add equals negative 5? Negative 6 and positive 1. Right? Multiply negative 6, add those together, negative 5. So now what are my answers? What minus 6 is 0? Positive 6. What plus 1 gives me 0? Negative 1. Okay? And we're not quite done yet. When you have a quadratic and you're solving these, because we don't consider the plus or minus when we do radicals, we just consider the square root of 36 is 6. We don't say plus or minus 6. We have to test both answers. Most of the time, one of these is not going to work. Okay? So I'm going to do mental math here. For you, you can just plug these in your calculator. That the calculator should check for you. So to test 6, I would do square root 3 times 6 plus 7. Does that equal, right, this is the question I'm asking, does that equal 6 minus 1? Right, putting 6 in for x. So 3 times 6 is 18. 18 plus 7 is 25. What's the square root of 25? 5. What's 6 minus 1? So that one works. X minus 6 works. But then I need to try negative 1. So put negative 1 in for x. 3 times negative 1 plus 7. Does that equal negative 1 minus 1? So this would be negative 3 plus 7 is 4. What's the square root of 4? 2. What's negative 1 minus 1? Negative 2. Does that equal? No. So we would cross that one off and we'd only have 6 as an answer. Yet sometimes neither will work and we say no solution if neither one works. Sometimes both will work. Okay? But this is called an extraneous solution, a solution that doesn't work. So again, step 1, is my rational exponent isolated? And in this case, yes, all I have on the left side is 5 minus x to the 1/2 power. So I'm good there. Step 1's done. Now, I'm going to raise both sides to what power? The second power. Because 1/2 of 2 is 1 and that cancels out. So I get 5 minus x. Right? And now this means to FOIL, so let's do the shortcut again. Square the first. Take the first times second times 2. Square the last. Okay. And what happens is I get a quadratic again. So I need all of my terms on one side, so it's set equal to 0. So we're going to subtract 5 over, add x over. So I get x squared plus 3x minus 4. Now I need to factor. What do I multiply equals negative 4, but add equals 3? 4 and negative 1. Good. So what are my answers? Negative 4, because what plus 4 gives me 0. And then 1, because 1 minus 1 equals 0. But I'm not done because I need to check them. Okay? So let's put negative 4 in and check that. So you have to go back up to your original equation here. Put negative 4 in. So I'd have 5 minus a negative 4 to the 1/2 power. And I'm asking, does that equal negative 4 plus 1? So 5 minus a negative 4 is 9. This means square root. What's the square root of 9? 3. What's negative 4 plus 1? Negative 3. That one doesn't work. So let's try 1. So 5 minus 1 to the 1/2 power. Does that equal 1 plus 1? 5 minus 1 is 4. 4 to the 1/2 power means square root of 4, which is 2. 1 plus 1, 2. So that one works. So again, my radical is isolated. All I have on the left side is the square root. So I'm going to raise both sides to the power of 2. Good. That crosses that off. And then we can square the first, take the first times second times 2, square the last. It's quadratic, so we need all of the terms on one side. So add 3x, add 5. So I get this quadratic. And then I want to factor that. What do I multiply equals 14, but add equals 9?
2 and 7.
Good. X plus 7, x plus 2. So what would my answers be? -7, -2. Good. Okay. But I need to check them. So I go back up to my original equation. Always go back to your original. Let's plug in -7. So I'd have -3 times -7 minus 5. Does that equal -7 plus 3? Well, this would be 21. 21 minus 5 is 16. Square root of 16, 4. What's -7 plus 3? -4. That one does not work. So then let's try -2. -3 times -2. So this would be 6 minus 5 is 1. The square root of 1 is 1. -2 plus 3, 1. So that one does work. So what happens when we have radicals on both sides? You can't do step 1. You can't isolate it. But you're still going to do step 2 is what power do I raise both sides to get rid of that radical? Squared, because this is a square root, and I know to get rid of a square root, I square it. So if I square both sides, look what happens. Both of my radicals cancel out, and I just get 3x equals x plus 6. And this is easier than what we were doing before because this is not quadratic, it's linear. And those are easier to solve. Subtract x, divide by 2, so x is 3. Okay? You don't have to check linear. Those usually work because they're not considering the plus or minus like a quadratic does. Okay? So when you get something linear like we did the lesson before this, you can check, but it's going to be right. Those are going to work. Okay. If you look at the one below it, if I have two rational exponents, but they're on the same side, you want to move one to the other side. You never want to work with radical functions or rational exponent functions when they're both on one side. Okay, so for me, I'd rather use positive numbers. So this subtraction, I'm going to add this term over to the other side. Then I won't have any negatives. So let's add this term to the other side. So I get this. I get 7x plus 6 to the 1/2 equals 9 plus 4x to the 1/2. Okay? So again, I'm going to raise both sides to what power? Squared. Because that's going to cancel that off, because 1/2 times 2 is 1. So I get linear. Combine my x's, combine my constants. So I would subtract 4x, subtract 6, and I get 7 minus 4 is 3x. 9 minus 6 is 3. So I get x equals 1. Okay, if you keep looking down the page, you should see the next one. They're both rational exponents, but they're different. Okay, so this is where you kind of have to put your thinking caps on and think to yourself, what power, that's too far. What power could I raise both sides to, right, once I add that over, that would get rid of both fractions? So my first step would be add that over. That's still going to be your first step. You want one on each side of the equal sign. Okay? So x plus 5 to the 1/2, 5 minus 2x to the 1/4. Okay? I'm going to take that subtraction and add it over. So I have a 1/2 and 1/4. What power can I raise both sides to get rid of the fraction? If I use 2, think about if I square, 1/2 squared is 1, but 1/4 times 2 is 1/2. I'd still have a fraction. If I did 3, that would be 3/2 and that would be 3/4. What if I did 4? What's 4 times half? 2. What's 4 times 1/4? 1. So if I raise both sides to a power of 4, right, power to a power I multiply, this becomes 2, and this one goes away. Now I have something I can solve. Okay. It's going to be quadratic, but that's okay. I can do quadratics. So we need to break it down here. This is a binomial squared, so let's square the first. Take the first times second times 2. Square the last. And now we're kind of where we were in the beginning of class. I have a quadratic. I need to get all my terms on one side so I can factor it. So I'm going to, subtract the 5, add the 2x. So I get x squared plus 12x plus 20. Okay. Now factor that. What do I multiply equals 20, but add equals 12? 10 and 2. So what are my answers? -10 and -2. Okay. But since it was a quadratic, we do need to check our answers. Make sure they work, okay? So go back up to your original. You have to go back to the original equation. And this is where learning all our properties come in handy. I'm going to put in, let's do -10 first. So -10 plus 5 to the 1/2, and I could actually stop there. Why? Anyone see why? Why can I stop right here and I say, oh, that doesn't work? What? Yep, -5 plus 10 is -5. Can I square root of -5? No. So as soon as I wrote this first one, I saw that that's not going to work because you cannot have an even index and a negative radicand. So we'll cross that one off right away. Now we got to try -2. So -2 plus 5 to the 1/2 minus 5 minus 2 times -2 to the 1/4. -2 plus 5 is 3. This would be square root 3. This 5 minus a -4 would be 5 plus 4, which is 9, and that's 4th root 9. Does square root of 3 minus the 4th root of 9 equal 0? No, right? And you could try that in your calculator. So this would be an example where you get no solution. There is no value of x that I can plug in to make that work. Okay, so when you have two radicals and a number now, okay, you still want to do what I told you earlier. You want to separate your radicals. You don't want two radicals on one side of the equation sign. So that's still a thing. You still want to add, I would add the square root of x over because that's the subtracting one. So I can keep it positive. Okay, so still divide them up. You still want to do that. So then I have this, 5 minus x equals, okay. Now you're still thinking, what power can I get rid of the radical? Square root, okay, that's still the same. But this is where it gets a little bit different, is because now that square root cancels that out, but this is a FOIL, right? You just can't square the first term, square the second term, you have to FOIL. But we can use our shortcut, square the first, take the first times the second times 2, square the last. Well, I square the last, then that radical goes away, and I get x. Okay, so now, thinking caps again, if I have a problem that looks like this, what do I need to do?
Ask for help.
Cry.
So when you look at this, you should see you just have one square root. So it's like a problem at the very beginning. We need to get that square root by itself. So let's move the 1 over, subtract the x over. So then I get 4 minus 2x equals 2 root x. One more step, I'd have to divide by 2 because that square root needs to get by itself. So that means I divide everything by 2. So 4 divided by 2 is 2. Negative 2 divided by 2 is negative 1. And then this 2 divided by 2 cancels out. Okay. Now, how do I get rid of that square root? You would square both sides, yep. So that gets rid of that. This, I would use my shortcut, square the first, take the first times the second times 2, square the last. Now it's a quadratic. What do I need to do with quadratics? Get all my terms on one side. Very good. Okay, now it's backwards, so be careful when you go to factor. I'm going to say, what do I multiply equals 4, but add equals negative 5? Negative 4 and negative 1. So what do I get? 4 and 1. Am I done?
No.
No, because since it was a quadratic, I still need to check my answers with my original function.
Billy Mays here.
Man, these get
But
fun,
wait,
huh?
there's more.
All right, so 5 minus 4 minus the square root of 4, does that equal 1? Well, 5 minus 4 is 1. The square root of 1 is 1. What's the square root of 4? Does 1 minus 2 equal 1? No, that one doesn't work. So let's try 1. 5 minus 1 is 4. Square root of 4 is 2. Square root of 1 is 1. What's 2 minus 1? 1. That one does work. Thank goodness, right? Do all that work? Something better work.
And this is when you hear
Okay, so again, you want to separate the radicals. So we have to add that square root over.
But why are you just
Right?
in one column?
So then I have this. And then again, I'm going to do what to both sides? Square both sides. Very good. So that cancels that out. This one, I would use my shortcut. Square the first. Take the first times second times 2. Square the last. And that squared gets rid of that square root, so it looks like this. Okay? Because if that cancels that out, I still have an x minus 1. And like we talked about before, now I need to isolate this radical, just like I did in the beginning. So let's subtract the 4 over, subtract this x over, add this 1 over, so I get x. 6 minus 4 is 2, 2 plus 1 is 3. Okay. Now, when you get here, you should kind of foresee what's going to happen now that you're in that upper level math. What's going to happen if I divide by 2 over here? We're going to get fractions, right? We don't want to work with fractions. We don't like fractions. I understand that, okay? So instead of working with fractions, we know that if I square this, I square the 2 and the square root, right? That was one of our properties we learned, our product property to a power. Okay, so I can just do that. I can have x squared, take the first times second times 2, square the last, and then this would become 4 parenthesis x minus 1. Because that square root is going to get rid of that, right? And that's going to become a 4. So this becomes 4x minus 4 if I distribute. So to get this set equal to 0, I have to subtract the 4x, add the 4, and then I'll have my quadratic. So I'd get x squared plus 2x plus 13. What do I multiply equals 13 but add equals 2?